After discussing a problem about multiple shafts, now let's discuss a continuously varying bar. A torque T is applied as shown to a solid tapered shaft AB. We cannot use phi equals to TLGJ anymore. No, we cannot use it. Show that by integration that the angle of twist at point A is phi equals to 7TL divided by 12 pi g times c to the power 4. C is the radius of the upper surface, while 2c is the radius of the lower surface. In this case, still we assume g and t are constants for the entire bar. However, j is a varying quantity with respect to x, because j equals to pi divided by 2 r to the power 4. But in this case, r is not a constant. R is varying with respect to x in this case. So in this case, we know that the torque is the same to all the cross sections inside the shaft, and that the shear modulus is assumed to be the constant. However, j is a variable of x because you know j equals to pi divided by 2 times to r to the power 4. But in this case, r is a variable instead of a constant. Therefore, we must obtain an equation of r in terms of x. So we know that at x equals to 0, the radius is 2c. X equals to 0. When x equals to 0, the radius is 2c. When x equals to L, the radius is c. Then we can write the linear equation like this. By a series of simplification, we get Rx equals to minus c over Lx plus 2c. Then we can rewrite Jx in this form. We can rewrite the polar moment of inertia in this form, but since it is power 4, which is an even number, then we can just switch the symbol inside this bracket. So the polar moment of inertia will be written in this form. Before we integrate this stuff, consider this integral and the Jx. Later on, the Jx will be put in this integral and it will be integrated. To simplify this integration, let u equals to c divided by Lx minus 2c, then dx equals to L divided by c times du. The lower and the upper limits of the integral consequently will become minus 2c to minus c respectively. Now we consider the torsional displacement formula in the integral form, which is this. Now we put our Jx into it and we take this constant out to get something like this. Also, since dx equals to L divided by c du, so there is an L divided by c occurred here, then the whole bracket becomes u, and the integral becomes du divided by u to the power 4 from minus 2c to minus c. Consequently, keep doing this integration, you will find the final answer to be verified like this, exactly the same. So it is left to you to read.